Welcome to the megacity of Shenzhen. Just bear with me, this is all leading to the subject of self-driving cars. This city is known as the Silicon Valley of China, and is home to 22 million people. It is by no means China's largest city, but it is perhaps the most remarkable. You see, just 40 years ago, this was a nondescript rural fishing village. And according to the local government, this city is only just getting started. While many people have never heard of Shenzhen, it is home to many famous high-tech companies that you certainly have. Companies like Huawei, Tencent, DJI and BYD, to name but a few. And being a new city, and filled with technology and engineering companies, meant that Shenzhen got to be the experimental proving ground for new technologies. For example, nowhere in the world has embraced electric vehicles like this city. Over 30% of vehicles here are electric. All of the 17,000 city buses are electric, as are the 22,000 taxis. All 100,000 cars of the ride-hailing fleet is also electric, and that's without the 1.5 million private EV cars. By the end of 2026, the proportion of EVs is expected to reach 50%. That all sounds great, but so what? Well, over the last year, we have noticed the introduction of LiDAR systems on private cars, and the scale of the rollout has been staggering. From noticing one or two vehicles about a year ago, they now appear everywhere, and not just on high-end car models either. It seems that China is betting big on autonomous vehicles. As well as Level 2 self-driving features for private cars, there are now Level 4 autonomous taxis too. China is not the first place to have Level 4 self-driving taxis. In the US, the company Waymo has around 2,500 of these. What is significant here is the speed of rollout. There are already over 1,000 of these fully autonomous taxis in this city, and by the end of 2026, there will be 10,000. In this video, we are going to talk about the key technologies that underpin self-driving, in particular, LiDAR. So, it's time for a deep dive. This video was actually inspired by a single taxi ride. I need to be clear, my human assistant is probably the world's worst backseat driver. Unless he is at the controls, he has the mental bandwidth to overthink the laws of motion and is constantly estimating probabilities. Terrible, and often rather terrifying probabilities. This is a man whose own family refuses to sit next to on flights, unless he promises to stop discussing all the things that can go wrong, and their horrifying consequences. Mind you, he is a former aerospace engineer, so perhaps ignorance really is the true path to bliss. And then I realized that when such a man is completely at ease, in a self-driving car, it was clear that something interesting was afoot, something that is fundamental to how humans get to move around the planet that they inhabit. So we dug deeper, and this video is the result of our investigation. On this channel, we normally conduct citizen science experiments, or we build interesting science gadgets. In this video, we are going to try and do a bit of both. We will be avoiding any politics, but this is a subject that for some, will stir political emotions. If you are the sort of person that wants to comment on that kind of stuff, well, please just be warned, this channel might be small, but we have slowly built a wonderful subscriber base, of level-headed and smart people. If you post political bullshit, expect some pushback. But, if you want to argue about the engineering or the physics being discussed, you will be warmly welcomed to our little community. That said, if you are one of those people that just hates China, then, all I can suggest is that you wake up, get a passport, and travel around a bit. Your human life is just far too short to have not invested just a little of your time to see what is out there on this amazing planet, and all of the wonderful possibilities that it holds. Anyway, with that out of the way, let's get on and talk about autonomous cars, and how LiDAR is changing how the whole ecosystem works. I guess we should try and answer a really fundamental question. Why do we even need self-driving cars at all? Given the demographics of the viewers on this channel, most of you would probably consider yourselves to be pretty good drivers, and I am very confident that you would certainly rate your driving prowess as being above average. According to a survey by the American Automobile Association, 93% of drivers consider their driving to be above average, which is clearly bloody impossible. But the truth of the matter is this. As a species, humans are really shitty drivers. You just need to look at the statistics to see that. Under 50 years of age, traffic accidents are the leading cause of death. In fact, per mile, traffic is as dangerous as space travel. And yes, I know, I am taking liberties with statistics here. After all, that number is based upon miles traveled, and space stations, like the ISS, orbit the Earth every 90 minutes. But then, nobody drives their car in the total vacuum of space, and at Mach 25, while drinking recycled piss, and worrying about bumping into objects smaller than a grain of rice. So, perhaps the real question is this. When it comes to skills like driving a car, can a machine do better than a human? After all, in the last 50 years, more people have died as a result of traffic accidents than currently live in the whole US state of Texas. So, clearly we need to find a better way to do this driving thing. And, we have no confidence that this is a problem that can be tackled with just cameras. I know, there are some companies out there that think this is a concept that can be solved with cameras alone, sort of mimicking how humans do, using essentially just their eyes. But we have our doubts, and so do many industry experts. Frankly, a self-driving car should not suffer from the same optical limitations that a human does, and unless full self-driving cars can be safer than a human driver, and safer by orders of magnitude, then it is essentially a flawed technology. It isn't enough to be able to autonomously drive around under ideal conditions. A credible self-driving system must be capable of being just as safe under any ambient lighting and weather conditions. And we need to also be very cautious when comparing the capabilities of the human mind to the processing of machine learning algorithms. Artificial intelligence is very good at sifting through vast amounts of data, but a human brain is far better at making inferences based upon very sparse data sets. And so, adding more sensors, like LiDAR, to a platform that is already very optimized for high-throughput data processing, would seem like a total no-brainer. There are many sensors on modern cars, and for cars that have some amount of autonomous driving capabilities, they are an essential part of the package. Sensors like cameras, ultrasonic proximity sensors, GPS, millimeter wave radar, thermal cameras, and of course, LiDAR. LiDAR stands for light detection and ranging, and together with cameras, are the primary sensors for a self-driving vehicle. It certainly doesn't mean that any other sensors are unnecessary, far from it. We firmly believe that adding more sensors to an autonomous vehicle can only improve the performance and safety of such cars. From a safety perspective, there is no downside to increasing situational awareness for these platforms. LiDAR, as the name suggests, is analogous to radar. Its output is a point cloud, a series of discretely separated points, that give a representation of the distance to anything in range, within the field of view. The fundamental operation of LiDAR is quite simple to understand, but, let's start off with laser range finding as a concept. This is a cheap laser range finder. It uses the time of flight of pulses of infrared laser light, to measure distance. Time of flight, literally just means the time it takes for a laser pulse to travel to an object, and then be reflected back. Here, you can see this rangefinder in action. And, using a little infrared night vision camera, that we made in a previous video, we can even view the infrared pulses of light. The pulses are pretty bright, as this rangefinder can be used to measure distances to objects that are over a kilometer away. Conceptually, a LiDAR device can be thought of as hundreds, or even thousands of rangefinders in an array. But of course, that would be horribly expensive and pretty wasteful. The solution is to scan one or more lasers across the field of view. But, how exactly is that done? To find out, we decided to reach out to some local Chinese manufacturers of automotive LiDAR systems. We sent emails to Robosense, Huawei, Hersey and Livox, which basically are the four biggest in China, which kind of makes them the largest in the world too. We didn't really expect anyone to respond to us. We are a tiny channel, and we don't accept sponsorships. But out of the blue, one company did reply to us, and even invited us to their facilities.
Robosense Technology has posted its first quarterly profit on the strength of new digital LiDAR technology. The company expects more growth as it ramps up expansion into the robotics business. Its CEO and executive...
To be honest, we were amazed that any of the companies we contacted would give a rat's ass about a tiny channel like this. So we immediately headed over to meet them, before they had a chance to come to their senses and change their minds. Once inside the Robosense campus, we were not allowed to record any footage, but the team were incredibly helpful, and allowed us to spend hours talking with their senior engineers. Significantly, we got to learn a lot about how LiDAR systems work, and how they have evolved. Early systems used arrays of emitters and detectors that were rotated around on a drum to allow them to scan the environment. They are still used, as they have the advantage of having a field of view of 360 degrees. Later, these were optimized to reduce complexity by scanning with an oscillating mirror. This confined the field of view, but increased the reliability, while reducing the system cost. These oscillating mirrors are sort of like laser galvos, but they don't need to have linear position control. Later, as the need arose for faster scan rates, and even more reduced costs, the scanning was performed with rotating polygon mirrors. This allows the number of emitters and detectors to be reduced. Some of you might be wondering, what the false color in the point cloud represents. This is a measure of the reflectivity of the target. You can see that highly reflective things, like road signs and car license plates are red, and low reflectivity objects, like the asphalt of the road, is blue. Later generations of Robosense LiDAR systems used a custom-designed, 2-axis, MEMS mirror system. Again, this allows even greater cost reductions, which has driven the wide-scale adoption of these systems. Currently, this is probably the most ubiquitous system on the roads of Shenzhen today. But, it seems that Robosense is not done with the innovation yet. Their latest systems are really pushing the boundaries in every dimension. Not only is the performance being increased, but costs are being driven ever lower. Welcome to the age of solid-state LiDAR, where over 1,000 separate laser beams are used to increase the situational awareness of vehicles. There are no moving parts in solid-state LiDAR. Essentially, this uses a camera-like array of single-photon detectors, paired with an equally dense array of V-cell laser diodes. Put simply, the scanning is now done at a chip level, so the costs can scale down too. And, this is the calculus that changes the game. What used to cost thousands of dollars a few years ago, is now in the region of $200 a pop. So, if anyone tells you that they won't put LiDAR on your car, because it costs too much, well, they are either bullshitting you, or they are bloody delusional. And before the Tesla fans start typing their vitriol into the comments, I am not saying that Tesla's full self-driving is better or worse than any other. But, what I am saying, is that adding LiDAR to Tesla vehicles, would only make them safer. What LiDAR offers, is a ground truth for distance, and now that China has seriously lent into the technology, and manufacturing at scale, there is literally no reason for it not to be adopted universally. So, before we visited RoboSense, we had a feeling that something major was changing in the market. But after having talked to their team, we were absolutely gobsmacked by just how advanced, and how affordable, these sensors have now become. Ignoring all the sensors on a car for a moment, let's just have a quick discussion about the algorithms that actually drive the vehicle. There are some myths that surround the subject of artificial intelligence that I would just like to dive into. I want to start with how artificial intelligence performs human-type tasks in the real world. Let's take this simple example of my human assistant, opening this soda can. It's a pretty mundane task for a human. In fact, any human can be taught to do this with as little as one training example, assuming that they have already developed fine motor skills. Actually, you could demonstrate this to an uncontacted Amazonian tribesman, and they would be very quickly able to do the same thing. But, to train a machine to do the same task, requires millions of training examples, and even then, there would be a lot of corner cases that would cause problems. Humans are just good at this kind of thing. And if anyone mentions these thinly disguised racist videos, as counterexamples, then frankly they can go and get fucked. These chaps were just exploited for clicks, and weren't given even a single example of how to open the bottles, and had no context to fall back on. It would be rather like asking the smartest human being that ever lived, Isaac Newton, what all of our modern road signs meant. To him, it would be a bunch of gibberish. Which brings us on to another common myth. An often quoted falsehood, is that a 17-year-old human, can be taught to drive a car with just 20 hours of tuition. So, a machine that has millions of hours of training data, will be infinitely better than a human. But really, a human cannot be taught to drive in just 20 hours. However, what they can be taught in that time, is how to operate the physical controls of a motor vehicle. This assumes that the driving student has already spent the previous 17 years, learning collision avoidance, understanding how distances relate to their perception of vision, and figuring out how to judge velocity. And that is without the years of experience being a pedestrian, and interacting with traffic, and figuring out how to do things like, crossing a road. In addition to that, the average American by the age of 17, has accumulated somewhere between 50 to 100,000 hours of time as a passenger in motor vehicles. So, I am kind of curious, as to just how much driving tuition, this guy needs, to pass a driving test in the state of California. Which brings us to the final myth about artificial intelligence. It is widely stated that given enough scaling, power and time, machine learning will reach the level of general intelligence of a human brain. This is probably impossible, even if enough GPU capacity was installed, to try and emulate every single neuron, and synapse in the human brain. A data center that had 1 million GPUs, costing around $50 billion to build, and consuming more power than San Francisco, would still be unlikely to be able to train a model to drive a car as well as a human, if it just had 2 cameras for sensors. Nobody yet fully understands how the human mind actually works. Each one is unique, and imperfect and flawed, and yet, it can process and learn at the same time. But, I'm jolly glad that it does work so well. Honestly, I would be completely screwed without my human assistant. Somehow, he can see things that I can't in those bloody annoying captures. As we were editing this video, it quickly became obvious that we had screwed up. This was supposed to be a short video, but the topic kept expanding, and suddenly it was in danger of being over an hour long. So, we have made the decision to split this up into 2 or perhaps 3 parts. We really don't want to inflict very long videos on anyone. And, don't worry, you won't have to wait for too long for the next installment, it is almost completed already. And in the next episode, we will be showing you how we built a LiDAR detection camera, and went out and about to see just how many LiDAR-equipped cars are actually on the roads. The results were quite revealing. As well as a special LiDAR imager, we also took a look with our high-speed camera. We wanted to take a look at the actual patterns of the laser beams, as they are scanned across the field of view. And then we are going to take a deeper dive into systems that only use cameras, and why perhaps, once wide-scale adoption happens, this might not be the way that the industry chooses to go forward. At least, not here in China at any rate. Then, we are even going to do some experiments, using stereo camera streams, to try and perform some estimation of the distance to objects. Our results weren't perfect, but they were pretty interesting, and shows what can be done in the absence of LiDAR sensors, even with our own shitty experiments. And finally, do you remember this miniature Geiger counter, that we reviewed over a year ago? Well, it just started beeping, to indicate it was low on power. It seems that the manufacturer's claims of battery lifetime were pretty much spot on. What is amazing about this is the coincidence of the timing. We have just been sent this little thing to review. This is also a small key fob type Geiger counter that has a display. We will be reviewing this little thing pretty soon. Anyway, that's all we have for you today. We hope you enjoyed our little video, or at least found some parts of it interesting. If you got this far in our video, then hopefully you can also help out with the care and feeding of YouTube's evil algorithm. And besides which, those like and subscribe buttons are not going to press themselves. We don't have any sponsors, nor are we looking for any either. At least this way, we can say what we want, and we can pick and choose the subjects we actually want to cover. If you have any ideas for topics you want us to look into, please drop them into the comments. We do read all the comments, and even reply to most of them. This is a hobby channel, so we don't have a lot of resources with which to make these videos. So if you want to help out, you could always drop us a super chat, or just buy us a coffee. It is our sincere hope that you got to learn at least one new thing from watching this video, and that it was worth the time you invested. After all, time is the only truly valuable resource that we have. And please don't forget to share your video ideas with us. Good ideas are welcome, bad ideas are tolerated, because the only truly tragic thing in this world is to have no ideas at all. And next, perhaps you want to watch one of these marvelous videos.